All right, thanks for coming to our presentation. My name is Ramji Srinivasan, and we're going to talk today about why 13 parameters on a flow panel should be good enough for anybody, right? This is the immunotherapy drug developer's question. My drug just hits the T cells. Why should I even bother looking at any other immune cell types like B cells, NK cells, etc.? Even if those cells are affected by my drug, I wouldn't know how to interpret those results. So that's the question, and here's a short answer, which is those cells types might be drivers of response. So as you increase the number of subsets that you look at with your cytometry assay, you can find more and more cell subsets that could potentially be associated with response. So for example, over here on conventional flow, we have different panels laid out: a 4 marker, a 13 marker, 25 marker, and 41 marker. And the black line over here is the number of markers and the number of subsets analyzed. As you go from 4 to 13 markers, you can start to find cell types like CD14 positive cells associated with monocytes that could potentially drive effectiveness. As you bump up your cell types, you could potentially look at subspecialized T cells like memory CD4 T. And as you go even higher, you can find new cell types like TIM3 that could be associated with exhaustion or potentially effectiveness of your drug. So this is the short answer, which is why bother looking at anything other than just the narrow T compartment, is because those cell types could mean the difference between success and failure. Okay, now we just said a lot of stuff here. Let's go into more detail. So what does a 4-color panel get you? And remember, this is the original panel that a lot of people use. You have number of markers over here, number of cell types and subsets. So let's go into more detail on each of these. So if you start with the 4-marker panel, you can imagine looking at CD3, CD4, CD8, CD45. Here's a lineage tree on the right-hand side. So it starts with leukocytes. You can see T cells, and then potentially double negative T cell, CD4, CD8, and double positive T cell. As we count this up, we can find 5 unique subsets. So starting with the T cells, all the way to double positive T cell. Okay, with me so far? So this is a 4-marker panel. Now, let's try to bump up the resolution. What do you gain from going to 13 markers? So this is a 13-marker panel with all the markers we just saw plus additional markers. Now we get a little bit more complicated of a gating tree. So you can see again total live cells over here, and then you can see additional cell types. So let's start counting. We got 1, 2, 3, 4, on and on. I won't bore you with all the details, but we go to 42, 43, and we're 44 individual cell subtypes here. And now you can find cell types that are associated with potential response, like CD14. So this could mean the presence and activation state of monocytes, which could influence the effectiveness of immunotherapies. CD14 positive monocytes can turn into dendritic cells and macrophages, which are crucial for antigen presentation and initiation of immune responses. So that's an example of going from 4 to 13. You automatically start to find new subsets that potentially can be associated with the response. Okay, should we just stop here? I mean, we already did a 3x increase in markers from 4 to 13 that drove a 9x increase in subsets. Well, our argument is that potentially higher resolution techniques may be very valuable. So what happens when you go to 25 markers? We can count again. We start with 1, 2, 3, 4, and then on and on until we get to 49. But the careful reader will see these little numbers over here: 4, 4, 4, etc., 3. What do those mean? These are what's called state markers, and let's start counting these up as well. So in that little tree, you'll see a T cell potentially with a little number over here, and that just means the number of state markers analyzed with this immune subset. At that top level T compartment, we analyze 4 state markers: PD1, HLA-DR, CD38, and CD25. So we get 4 markers there. So now let's go back to our tree and let's start counting. We start at 1, but since there are 4 markers over here, we're going to go to 5, then 9, because there are 4 markers on the adjacent cell, and again 13, etc. And iterating through the tree, we actually get to a much higher number of 298. So now you can see what cell types might be revealed by this increase. So for example, if you add in these additional markers like RA, CD45RA, CCR7, CD2728, you could find specialized T cell subsets that drive better checkpoint inhibitor responses. Specialized ones like naive CD8 T cells or high levels of memory CD4 T cells. So that's the kind of example of something that's associated with an immunotherapy. So we started with 4 marker, we went to 13 marker, and then we went to 25 marker. At 13 marker, we found subsets like CD14 positive subtypes. And then as you bump up your resolution, you can find different T cell types like memory CD4 T cells, which could drive immunotherapy effectiveness. So a 2x number of markers increases 6-fold increase in subsets, which is really exciting. So as we go to 41 markers, we can see that the gating tree becomes even more complex. If we start at the top left, we can see there's one. We'll start with 1 over here, and there are 22 state markers alone. So then we'll go increment next to 23, on and on through this tree until we end at 735. And these new cell subtypes aren't just academic exercises. These are important cell types like potentially TIM3. And if you block TIM3, you can stop T cells from getting tired and help those T cells to work better. So this is the relevance for a drug developer as you go from 4 to 13 to 25 to 41. From 4 to 13, you can find things like CD14 positive. Then you can find memory CD4 T cells. Then you can find things like TIM3, which is associated with exhaustion effectiveness. These are just case examples, but you get a 6 to 16-fold improvement in subsets identified with these higher dimensional panels. Now, this is the immunotherapy developer's question answered. My drug just hits the T cells. Why should I bother looking? Even if all those other cells have affected, I don't know how to interpret those results. Our suggestion is you should look because you can find these critical immune subtypes, and these could drive potentially safety, toxicity, or response, and those extra subtypes might predict the difference between success and failure for a drug. So with that, thanks for coming to our talk at TACO, and if you have any questions or are interested in using TACO for your immunotherapy programs, feel free to contact us.